All right, folks, it's Back in Action here. In this video, we're going to go through two major skills. The first being writing equations for quadratics based on particular characteristics. And then at the bottom, we're going to review the discriminant and how it can be useful for you in working with quadratics. So let's jump into our first problem here on writing the equation for a quadratic. And in this particular problem, they're going to provide us with the vertex and a particular point. Okay, now the vertex is going to give us this HK pair, and the point it's going to pass through is going to give us a nice XY pair. So since it started off with our vertex, we're going to start with that vertex form from your Algebra 2 days. So we're going to have y equals a, and we want to include that a because we're looking for a particular point, and then we're going to have x minus h squared plus k. And now we can start substituting in. The HK is going to go in for, just as you would expect, the H and the K. And I'm going to go ahead and start this off. The A is what we're trying to solve for here. So for our minus H, I'm going to fill that in right away as a plus 3 squared. And since my K value is that 2, I'm going to put a plus 2 here. Then I can also fill in this XY pair, working with this. This is going to give us our X and our Y. So the y is going to go here, and the x is going to come in here as 1. At this point, when we do all this substitution, we've got everything that we need to solve for this a value. And solving for this a is something that a lot of students forget to do on these problems. I'm going to subtract that 2 from each side and get myself a negative 8 on this side. On the right-hand side, I'm still going to have my a. And then I'm going to have this 1 plus 3 is 4, and I have to remember to square this. So it's actually going to then give me a 16 on that side. If I divide both sides by 16, I get a nice a value of a negative 1/2. Now I'm going to have two different choices of how I can write this final equation. I could leave it in this vertex form by substituting that negative 1/2. And then I'll have my x plus 3, we're going to use that vertex again, squared, plus the 2. And then sometimes this will be our vertex form. Depends on what the problem asks for. And then another possibility is it could ask for it in standard form. And if it asks for it in standard form, we're going to need to expand this whole thing out. So if it asks for it in standard, we'll have a negative 1/2. We're going to expand that x plus 3 quantity squared to x squared plus 6x plus 9, and then plus 2. Then we'll go ahead and we'll distribute that 1/2, and we'll have y equals a negative 1/2 x squared minus a 3x minus a 9/2 plus this 2. And then, of course, we would need to get common denominators because we need to write this as a single fraction so that we can pull all of that together. So our final answer would be y equals a negative 1/2 x squared minus 3x, and then we're going to have minus a 5/2. We would not, under any circumstances, want to write this as a decimal there. Okay, so you would want to leave that as that nice fraction. This would be our standard form. So you'll just have to read the directions carefully. On the next problem, we are going to be given slightly different information. This one is going to give us the zeros of our quadratic. These are going to get substituted in for what we typically call P and Q in the intercept form. And then our point is still, again, going to be an XY pair. So if I substitute these in, I'm going to have an A, and then we would write our intercepts in those nice factored forms. If we want to substitute the y in first, we could do that. We could fill that in as a negative 5 there. And then these would typically be x minus p and x minus q. So my x value this time is going to go in two different places. So I'm going to do a 2 and a 2. Now I'm going to do minus a negative 4 for one of the intercepts. So that'll become a plus 4. And then I'm going to do minus a 6. So we've got our intercepts that are going here, and then our x values from our particular ordered pair. Now we're just going to do some quick little algebra. And I'll have my negative 5, and I'll have my a, and a 6 times a negative 4 that I can see is going to be a negative 24. So I'm going to divide both sides here by a negative 24. This one, of course, is not going to clean up in any particular way. Those will become pluses. So my A value is 5/24. So this isn't nearly as pretty of an answer, but that's okay. So this problem, I could jump into the intercept form, and I could say y equals, and I want to use that 5/24, and then I'd write x plus 4 and x minus 6. This is going to be called our intercept form. So sometimes it'll tell you just to leave it in intercept form. We might need to also expand that, in which case I can say y equals 5/24. I'm going to expand this, x squared minus 2x minus 24, then distribute my 5/24, and that's going to give me y equals 5/24 x squared. When I distribute the 5/24 next, it is going to reduce. That's going to give me a 5/12 x, and then I distribute it to the last term, and that's going to give me a minus 5. This again would be our standard form. Okay, now the next thing that we want to take a quick look at is the discriminant. The important thing to remember about the discriminant is that the discriminant is only this portion under the radical. It's specifically the b squared minus 4ac, not the radical itself, okay? So we only want the value under. Now, the reason the discriminant can be helpful for us is that in our quadratic formula, if we know that our discriminant value is something positive, then that tells us something about the graph without actually having to graph, okay? So if our discriminant is something positive, keep in mind that's all this is telling us here, if it's something positive, then we are going to have two real solutions. Again, without doing any work, we know that our graph is going to somehow cross this x-axis in two places. It could look a variety of ways, but it's definitely going to cross the x-axis in two different spots. If, however, the discriminant is negative, meaning I have a negative number underneath the radical, we know that our negative numbers are going to give us imaginary values. So if our discriminant is negative, then we automatically know without any math that there is no real solution. So that means graphically our equation must look something like this. It's going to be some type of a parabola that is never actually going to cross the x-axis. The last one is if our discriminant equals exactly 0. And if it equals exactly 0, then there will be one repeated solution. And graphically, that means that our parabola is going to sit right on that x-axis. So it's just going to have this one spot. So the nice thing about understanding this discriminant is it allows us to be able to easily see and know some things about our graph. So let's look at a couple examples and how those work out like that. So on our first one, if we wanted to calculate our discriminant, remember that's b squared minus 4ac, so that's going to be, in this case, 3 squared, oops, haven't done that in a while. Okay, b squared, so 3 squared minus 4 times 1 times negative 4. And that's going to give me a 9. And this portion is going to give me a plus 16. So that's going to be a nice 25. So that means that my graph is going to cross the x-axis twice. If I solved this, okay, if I actually tried to solve this little equation, this one conveniently factors for us. And if we factored it, we'd get x plus 4. And we'd get x minus 1 equals 0. And sure enough, we would get x equals negative 4 and a positive 1, just like we would have expected. A positive discriminant tells us we should get two values. Now, on this next one here, I've got this x squared plus 4. Now, that, of course, rewrites to an x squared plus a 0x plus a 4. And if we did its discriminant, we would get 0 minus 4 times 1 times 4, which is, of course, going to give us a negative 16. And if we tried to solve that problem, we'd get x squared plus 4 equals 0, and we'd move that 4 to the other side, and sure enough, if we do square root and square root, this is going to give us a plus or minus 2i. The other thing that we can clearly recognize is that this particular equation, if we graphed it, is a very, very easy parabola to recognize. It's upward turning, shifted up 4 units, so we know that this parabola is going to look like that. The last one that we're going to look at is going to be our one repeated solution. So let's calculate its discriminant quickly. So we're going to have 36, okay, I'm jumping just straight into that b squared, so that's my 6 squared, so 36 minus 4 times 1 times 9, well, sure enough, 36 minus 36 gives me a nice 0. So since my discriminant is 0, I'm looking for one solution. If I take my whole equation and I go ahead and I factor that one, it's going to factor into x plus 3 and x plus 3 equals 0. So sure enough, we just get x equals a negative 3. If you typed this one into Desmos, okay, what you would find is that's going to be just a nice upward turning parabola that's just touching the x-axis at a negative 3. So these are some really quick algebra, really Algebra 1 review items. If these don't feel super familiar for you, you might want to make some note cards, jot this down in a way that you are going to remember it, because these are considered our basic quadratic skills.